Now UDP. UDP is User Datagram Protocol, and the biggest thing to remember about UDP is that UDP is connectionless. UDP does not have to verify a connection before it starts sending data. UDP doesn't do a three-way handshake. UDP doesn't care if the data got there or not. It's not, well, it cares that the data got there, but it's not going to verify that the data got there. It's not going to wait for a read receipt. It's not going to number its packets. It's not going to perform retransmission. It's not even limited to one-to-one communications. We may send UDP over broadcast. We can send broadcast packets that are UDP because if we're sending a broadcast message, we don't necessarily want anything back. So we're just sending these packets broadcast over UDP. So why would we use UDP? Why would we want to send a packet or send any data at all that we don't verify that it gets back, that it got there, or that we don't want to verify that we can retransmit it if it's corrupted? Well, think about streaming a video. If you're streaming a video, that's taking a lot of bandwidth, especially with those high quality Netflix everybody has, or the high quality online HBO that only a couple people seem to have. You're streaming video and you're streaming a lot of bandwidth. Now, if every time a single packet of data got to you that was a video packet, the server would have to wait. If you were running over a TCP connection, the server would wait for you to communicate back to it and say, yeah, I got this packet, before it sent the next one. You think you have problems with buffering now. Imagine if the server had to wait for you to respond back and say, yeah, I got this packet before it sent the next packet. It would be ridiculous. So that's why we use UDP for certain things. UDP is when our priority is making sure it gets there and it gets there fast. Or it gets there and it just streams as live as possible. So that's our big deal with UDP. Now, UDP is also useful for small packets because our UDP header is a lot smaller. It's only 8 bytes. We don't need those 12 other bytes because we don't have all that other information, like which packet this is, or making sure that the packet's not corrupted. So we don't have all that other information. TCP numbers their packets, and they also put in checksums to make sure that the packet isn't corrupted. UDP doesn't care. So UDP is only going to have that 8-byte header. It's connectionless. We don't perform a three-way handshake. We don't wait for a read receipt. We just send these packets. There's no error recovery. If a packet is received and it's corrupted and it's UDP, oh well. You'll get a video that's a little bit fuzzy, or you may get, say you have a Skype conference call with somebody. It may break up a little bit, but when the connection gets restored, your computer isn't going to back up to that point in that Skype call and then restart over again. It's streaming. It's just going to keep going, and those broken up packets, oh well. So there's no error recovery. They're small packets. We mentioned they're small packets, so because they only have an 8-byte header size. And we have here that they're distinct chunks. Now, what we mean by distinct chunks, compare that with our data streaming from our TCP. Now, our TCP, like we said, because our boxes are numbered, because our packets are numbered and they're ordered, we can just fill those packets up all the way. It doesn't matter if the end makes sense or not, and then just send it, because our next packet will pick up where it left off. UDP, that matters. What goes into those packets have to make sense within the context of whatever next level protocol or whatever program we're using is. Because if that program receives a packet and it doesn't get what that's saying, the next packet may not be the next intended packet. The next packet may get dropped, or the next packet may get corrupted. So we can't send a full box of UDP, so a full UDP packet, and then just say, oh, I can't, this UDP packet, I'm going to take this data and I'm going to fill the UDP packet all the way up, and I'm just going to cut this data off in the middle of a conversation and then pick it up with the next packet. It'll be okay. Well, guess what? That next packet may not get there, or it may be corrupted because you're not performing a connection-oriented connection. You're more worried about just how fast these packets get there. So you may have UDP packets that are not using their full packet size because they're breaking up into logical chunks. They're breaking their packet up into data that if our program or our next level protocol didn't receive this packet but only received this packet and this packet, it would be able to understand the message without the context of this packet. That's why file transfers can't be UDP. That's why we don't want file transfers that we want to make sure that the files are correct can't be UDP. Because if we're transferring a file, we're breaking up that file at illogical points because we can't fit the whole file into a single packet. So we've got to break it up at points that don't make sense in the context of opening that file in a program. If we lose a packet, that file's corrupted. So we have to transfer it with TCP because we need to make sure that every packet gets there and it's not corrupted and it's in the right order. So that's our two communications protocols. That's our difference between TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. And again, our communications protocols, TCP and UDP, are what let our next level protocols that we're about to talk, or that we'll talk about in a little bit, that's how they talk. Now, not all of the different protocols that we've talked about or will talk about are using TCP or UDP to know how to communicate. For example, we've talked about routing protocols, such as RIP. Routing protocols are simply protocols which analyze information and develop information for routing tables. Those protocols aren't delivering data anywhere. Those protocols aren't sending messages or downloading pages from web servers. So they don't need a communication protocol to work with them. They don't need a communication protocol to know how to transmit their packet sizes. They're just working with IP addresses and they're working with information that they're observing about the network. So that's how our communications protocols, TCP and UDP, work with our next level protocols. That's why our TCP and UDP are layer 4, because they know how to transport data. They know how to break up packages. Think of our TCP and our UDP as our FedEx and our UPS sort of our transport layer. And we'll move into our next different protocols, and we'll talk more about how our other protocols are either TCP or UDP and how those other protocols work with different types of data.